Today's creations stretch to the heavens, but their foundations are embedded deep in the past. The cornerstone for them all was the Great Pyramid. The rough appearance of the Great Pyramid masks the precision of its construction. Its limestone casing was stripped away centuries ago to rebuild Cairo, but the pyramid remains the most accurately built stone structure on Earth. It covers 13 acres, the equivalent of 9 football fields, yet each of its sides are accurate to within inches.
In my opinion, pyramids built Egypt. Because building the pyramids made the Egyptians to think about art, architecture, to think about astronomy, and this is why they became genius, because they have to build the tomb of the king who will be a god.
The ancient Egyptians set out the base like a compass. One side, aligned by the stars, runs north to south. With only geometry and rope to help them, it is baffling how they created a perfect square. Engineer Scott Steedman demonstrates one possible method for laying out a pyramid, which may have been used by the Egyptians 4,500 years ago.
One of the mysteries of the ancients is how they managed to survey structures as accurately as they did, as large as the pyramids in deserts just like this. There are a number of theories as to how they did it, but this is a simple way in which you can lay out a right angle. What we need is a little simple geometry and a piece of string. What I want to do is to find the exact midpoint and mark it, and then we'll use that to lay out a right angle off our north-south line behind me. And here's the exact middle. I'm going to mark that with a green piece of twine because I need to find that.
With the string, Scott forms a triangle. He loops the ends around 2 posts set upon the north-south line and pulls the middle of the string out to find the midpoint.
Right, here's the green marker. Now, the trick about this is it doesn't matter how hard I pull, because the tension is the same in both sides of the string.
He marks the midway point with a post. He repeats this the other side, again marking the midway point with a post. By aligning these 2 points with a string, Scott has created a 90-degree angle.
That's the original north-south line, and this is the new east-west line. The beauty of this system is that you wouldn't just do it once. You would go on from where I stopped, right around the pyramid, and then you would go back the other way anti-clockwise, and then back again clockwise. Each time you'd close out the error just that little bit more, until you got it to the precision that you wanted.
Dr. Howes has discovered the remains of the surveyor's original workings.
We found in our excavation holes about 40 centimeters in diameter, and no one understood the function of these holes. We found that these holes has to do with making the square base of the pyramid. After they finish the square base of the pyramid, they cut in the solid rock, and they made the base of the pyramid about 8 meters high, only from the rock of the plateau.
The stones were dragged from the quarry to a short ramp and then hauled up onto the base. Dr. Howes has discovered remains of the ramp which stretched 1,000 feet from the quarry.
The ramp, based on my discovery, is located to the southwest corner of the Great Pyramid.
After the stones were hauled up onto the base, Dr. Howes believes they were then moved upwards using a girdle or spiral ramp. This wrapped around the outside of the pyramid and was made from mud and rubble. spiral ramp grew higher as the pyramid was gradually built up. No one knows with certainty the exact ramp design. Other archaeologists believe the ramp was a straight one.
I prefer the long straight ramp option, partly because a ramp circling the pyramid would have been inherently unstable for the heavy loads to be dragged up it. And it's also difficult to understand how you could drag these heavy blocks round the corners on such a ramp.
But a straight ramp to the top would have ended up being a mile long, stretching far beyond the quarry. To retain a manageable gradient, its length and height would have needed continual adjustment. On the other hand, the spiral ramps have cornering problems. As the Great Pyramid grew higher, the stones became smaller. Rollers running under the stones may have been used here for maneuvering. The builders used only the simplest techniques.
The Egyptians used stone tools and copper tools, copper very frequently mixed with arsenic, which of course hardens up the copper, but iron was certainly not used. In fact, the Egyptians were very late into the Iron Age.
Without any sophisticated tools, the stones were fitted with watertight precision to a height of 480 feet. Until little more than 150 years ago, the Great Pyramid remained the tallest structure on Earth. When built to the top, it resembled a series of steps. It was then ready to be cased in top-quality limestone.
And then, of course, you start smoothing it off from the top down. So you do the top bit, then you take the girdle ramp down, then the next bit, and so on, until the whole thing is done.
After 23 years, Khufu's tomb, the largest pyramid ever built, was complete. Pyramids are the most enduring ancient structures on Earth, and the Great Pyramid is the only ancient wonder of the world standing today. It has been imitated many times. Its stable form inspired one of today's most famous architects, I.M. He designed the pyramid at the Louvre in Paris out of glass.
Pyramids built of stone is solid, it's for the dead, and I hope the glass pyramid is transparent, it's for the living. But one thing I learned to respect the Egyptians is the proportion of that pyramid, of the Giza pyramid. It's the only one that we came to that satisfies from both directions, whether you look at it head on or look at it at 45 degrees. It's neither too flat nor too peaky. So I think that proved a point that, to myself anyway, that the Egyptians were right 4,000 of years ago.
Khufu's pyramid was so admired that his son and grandson followed him, building their tombs alongside his on the Giza plateau. But the Great Pyramid has remained the father of all ancient structures.
The people came for the first time, they looked at it, said, God, how it was built, who built it? Arabs, when they came in the 9th century AD, they said that man fears time and time fears pyramids. It's true. The pyramids are immortal. It will live because of the way that the pyramid was constructed.
The techniques used to build the Great Pyramid would pave the way for the other 6 world wonders to follow. The Great Pyramid, the foundation for the other world wonders, was built in 2650 BC. It would take another 2,000 years before the next wonder of the ancient world was created. Across the deserts to the east, the Hanging Gardens adorned the most spectacular city on earth, Babylon. Although the royal gardens were constructed 2,000 years after the Great Pyramid, they have vanished without trace. Fragments of the ancient city survive, but the Hanging Gardens have been lost forever. Some scholars doubt whether they could have existed here. How was it possible to have built terraced gardens in an area without building stone?
Babylon's built on a huge, great, flat alluvial plain, and there's no stone nearby, so they have to use mud. And they would dig the mud from the riverbank, creating a sort of moat around the city. And then the mud would be formed into bricks. And then as it bakes in the sun, you would end up with really quite a sturdy product. You can't just take the bare mud and pack it into a brick. So he's processing the mud by stamping it and adding water to it to give it just the right consistency, so that when it is slopped into the mould, he has a brick which you can recognisably see as a brick and not just a heap of mud. Mud, when it's baked and compacted, is a very strong and capable building material. And there are many examples in ancient history of walls that are built to really quite a significant height using baked earth and mud. Sometimes that needs to be reinforced, perhaps with straw or reeds, which would be laid flat and then more earth compacted on top. But as long as you created a big, wide, massive wall, essentially, it would be a very strong and capable material.
Babylon was situated on the Euphrates in present-day Iraq. In the 6th century BC, King Nebuchadnezzar rebuilt it. The walls were so splendid that the Greek poet Antipater had included them as one of the 7 wonders. Herodotus was also impressed by them.
They formed a square. Along the top were walkways wide enough for 2 chariots to pass. There were 100 bronze gates in the circuit of the walls. It was some 56 miles around the whole city.
Behind the Ishtar Gateway, inside the city walls, the streets were laid out on a grid plan. Babylon was the most splendid city in the world. A blend of sophistication and order. King Nebuchadnezzar ruled Babylonia from his palace. He married Princess Amytis from the land of Media. Their marriage symbolized a prosperous union between their countries. Babylonia now looked forward to a period of peace and plenty. Above the palace, Nebuchadnezzar built the grandest celebration of this new era, the Hanging Gardens. They were a spectacular surprise for his queen. The earliest account of them comes from Brosnan, a priest writing 200 years after they were built.
And within this palace, Nebuchadnezzar erected the so-called Hanging Garden, because his wife, having been brought up in the country of Media, had a passion for mountain surroundings.
Gardens are often controlled by the monarch of a particular culture. That monarch is showing that he or she can control the landscape and can make it flower in a way that God cannot in the landscape around them.
In the Middle East, gardening was a respected profession. Plants were grown for medicine and also for the perfume industry. The importance of fragrance may explain why accounts record that some gardeners were blind and some female. Nebuchadnezzar's gardener was believed to have been an expert from Judea. Records show he was given special rations from the palace. The Babylonians had a great knowledge of plants. The gardeners in Babylon would have selected the best plants to thrive in the hot, arid climate. There are a number of ways plants have adapted to survive in harsh environments like the Middle East. One way is to have thin, needle-like leaves. Grasses and conifers are good examples of this. Their very small surface area ensures little water loss. Others have leathery or waxy leaves to prevent water loss. Often they are grey in color, which reflects the glare of the sun. Some plants have leaves covered in fine hairs. These reduce the drying effect of the wind and also trap the cold night air to keep the plant cool during the day. Oak, willow, and cedar, ilex, plane, and palm. The lists of the trees and the plants in the hanging gardens are endless. They were compiled by historians centuries later and are often inaccurate. It is believed the gardens contained many plants and trees from the land of Medea, the homeland of Nebuchadnezzar's queen. As well as adding color, the flowers of orange and lemon trees would have produced a fragrant scent. However, the gardens were planted out. They needed water. Ancient writers recorded that there were hidden machines used for irrigation. Scholars have investigated buckets on ropes, water wheels, and even the Archimedes water screw. This device is attributed to the great Greek mathematician and inventor. It is believed Archimedes created it while in Egypt, having watched villagers pump water from the Nile. But the Hanging Gardens were built 2 centuries before him.
The only device we have evidence for at that period is in fact the shaduf, a very simple tip beam device that's known as early as the 3rd millennium BC. You have a counterweight at one end and a basket on the end of a rope or a pole at the other that lifts the water up. We have illustrations of it from the 2nd millennium BC onward. We have illustrations of it in Assyrian art from the time the Hanging Gardens supposedly were functioning, and there are no illustrations of other devices that would have been suitable. So it seems to me that this is the only solution.
Today we overcome our engineering problems with machinery. The ancients often looked no further than human labor, and in Babylon there was an endless supply. The Western perception of the Hanging Gardens has been highly idealized. Terraced gardens with abundant water, even waterfalls.
In arid regions, in the desert, water is so precious it's like gold. They have to control how they use it very, very carefully. They let the water come in down channels, and then they release the water so that it just rushes out, just for perhaps 10 minutes a day, and then they'll shut it off again and conserve it for the next day. Just a tiny amount of water has created an intensity of color, green trees, which is just totally unexpected.
Water could have been taken from the Euphrates, carried or lifted up to a cistern on the top terrace. From there it would have trickled down through the different levels of the garden. The irrigation of the Hanging Gardens is only part of the riddle, taunting archaeologists. The more baffling puzzle has been to find their exact location. The city of Babylon was known across the ancient world, but accounts of the Hanging Gardens were hard to find, even at the time of their construction.
Well, the Hanging Gardens are a kind of historical mirage. We have sources from the 1st century AD that say there was hanging gardens at Babylon. But Herodotus, who's writing very close to the time the gardens supposedly were built, doesn't mention the gardens at all. If they were so spectacular, you'd expect him to say something.
It is likely they were destroyed within a century of their construction. After Nebuchadnezzar, Babylon became a pawn in the struggle between the Persians and the Macedonians, and was severely damaged.
We know that Babylon was very badly destroyed by the Persian king Xerxes in the 480s BC, and the fragile mechanisms and the fragility indeed of the plants themselves, one can't imagine that they survived that kind of ordeal.
Some archaeologists have looked elsewhere to find another location for them.
The most convincing explanation, which says that there is a confusion in the beginnings of this legend, and that really what the Hanging Gardens refer to are the palace gardens built by an Assyrian king in Nineveh, which was the great capital of the Assyrian kingdom, something like 100 or 150 years before Nebuchadnezzar.
Despite their short lifespan, the gardens have gained legendary status. They remain unique among the seven wonders as the only one displaying nature's beauty, and they live on as the most famous gardens ever. The balance of power in the Middle East would change, and with it the fortunes of Babylon. Persian armies under Cyrus the Great overran the Babylonian Empire. Just 200 years later, Babylon would be conquered once again, this time by Alexander the Great, who incorporated it into the Greek Empire.
Alexander was interested in Babylon as the center of learning, the center of power, the traditional center for Mesopotamia. And indeed, he died in Babylon and was planning his last campaigns there, and was, I think, planning to make Babylon the capital of his syncretistic empire. So he certainly saw Babylon as a key place in the geography of the world.
After his death in 323 BC, the empire was divided up amongst his generals. Ptolemy took Egypt, Antigonus seized Asia Minor. In between these two powerful territories lay the small island of Rhodes. The islanders allied with Ptolemy of Egypt. Outraged, the Antigonedes from Asia Minor attacked Rhodes with a huge fleet. Against all odds, the Rhodians defeated them and celebrated their victory by building a giant bronze colossus to their savior, the sun god Helios.
Helios was closely related to Apollo, the god of light, of truth, of vision. He is the god of the sun, who was especially worshipped on Rhodes.
There were many bronze statues on the island, but the Colossus was easily the largest. To build, it cost 300 talents, equal to 300 warships.
The Colossus was a memorial to themselves, to their victory, to their freedom, their continuing freedom. And as such, it was certainly worth putting a lot of money into. 300 talents, they had won it from the enemy. Why not?
Bronze casting was a major business on the island. Statues were mass-produced and exported to Greece and Italy. The sculptor chosen to create the Colossus was Harris of Lindos. One story recalls his initial design as being 60 feet tall, but the islanders insisted on a statue that was twice that size, 120 feet. Harris doubled his dimensions and set to work.
Harris was especially well qualified for this job because he had studied with one of the greatest bronze artists of the 4th century BC, Lysippus. Lysippus was known for producing many, many statues, 1,500 in his lifetime. And so in the workshop of Lysippus, one can imagine hanging on the wall a whole row of arms, a row of legs, body parts which were more or less interchangeable.
Unfortunately, none of these mass production techniques could be used for the Colossus. No bronze statue had ever approached 120 feet in height. Harris had to manufacture everything on site.
The casting would have been directly next to where the statue was to be put up. Probably a whole series of pits in which the pieces were cast. Those pieces would have been riveted together, and the statue would have been set up on the spot.
The basic techniques of bronze casting have changed little over the centuries. From a scale model, the first process is to make a copy. Today, a latex mold is filled with liquid wax. Harris may have used clay or terracotta molds. When the mold is pulled apart, the wax replica remains. Replicas are then covered in a heat-resistant coating and fired inside a kiln. The wax inside melts and is released through pipes and channels. The hollow replica can now be filled with molten bronze. When it cools and the casing removed, the finished bronze remains. The Colossus gradually took shape. Piece by piece, each bronze section was attached to a framework of wood and iron.
Iron had been in use for weapons, for tools. Iron was used also in classical times for the bronze casting industry. Iron pins were used to support a project during casting.
Keeping the statues stable was a problem. Stones were dropped down the ankles into the feet to add weight to the base. As the colossal sun god grew taller, the workmen needed access all around the statue. Harris's solution was to bank up earth around the Colossus with a spiral pathway, rather like a girdle ramp used in building the Great Pyramid. There was one drawback to this.
When Caries designed the statue, he would never have a chance to see what the finished work would look like until the work was finished, which is certainly a deterrent in producing a Colossus. You can't look at it at various stages of the process, put it all together, take it apart again. You have to wait till the whole thing is finished before you get your first view of what it's really going to look like.
By the time Harris reached the head of the Colossus, the mountain of earth was 100 feet high. Altogether, 225 tons of bronze was riveted into place. Gold rays were fitted to his crown, which pointed to the sun. After 12 years' exhausting work, the mountain of earth was removed. Harris's magnificent Colossus of the sun god Helios, 120 feet high, was left to stand guard at the harbor side.
Caries certainly must have found out how to cast a big statue like that in many pieces. What he overlooked, apparently, was finding out from somebody how to make it stand up.
When you scale up a structure, you have to think very carefully about how it's going to support itself. What works well when it's small may not work at all when it's large. If you scale up a hollow sculpture, for example, then the weight of the shell itself may overload it. And any tall, thin structure or sculpture will be much more vulnerable to wind and earthquake.
The Colossus stood for just 56 years. In 226 BC, an earthquake brought it crashing to the ground, burying several houses beneath it. With time, people forgot how it had once stood. During the Renaissance, Martin van Heemskerk, the first artist to draw the seven ancient wonders, depicted it astride the harbor.
Impossible. But as people tell the story over and over again, the statue gets bigger and bigger until a ship can sail beneath it. When a statue is standing on two legs, and it's a naked statue, as this would have been in the tradition of producing statues of gods and of heroes, it's the legs have to be close together to give it the support that it needs.
But the idea of the Colossus straddling the harbor still remains popular. Engineer Gavin Davis assesses the likelihood of this.
If the legs were together on the sculpture, it would be a lot more stable because the weight of the upper half of the body is carried vertically down through the legs. And then provided the foundations are strong enough, then you should have a relatively stable structure.
If the Colossus had stood with the legs apart, it would have been considerably weakened.
The key area of concern in the Colossus is how the weight load is carried down the two legs when they're quite wide apart. Once you do start getting any wind loading on this kind of structure, then there are obviously weak areas. Around the two ankles, for example, would be an obvious area of concern.
Over 2,000 years after the Colossus, Auguste Bartholdi designed the Statue of Liberty. He employed the greatest engineer of the day, the Frenchman Alexandria Eiffel. Avoiding the mistakes of the Colossus, Eiffel introduced revolutionary technology to ensure the Liberty would stand forever. The Statue of Liberty was an engineering innovation. Eiffel designed an iron framework to form a backbone. The statue, a hollow shell made from copper, was then hung over the frame. In 1986, after standing for 100 years, it was overhauled. Architect Blaine Cliver was a part of the restoration team.
The statue itself is 153 feet tall. That's all the way up to the top of the torch. Eiffel's design was light. It is a skeletal frame and is anchored to the pylons which are into the base, the stone base upon which the statue stands.
Unlike the Colossus of Rhodes, the outer casing carries no weight at all. Consisting of 300 copper plates weighing 80 tons, its weight is transferred by ribs and armature bars to Eiffel's central skeleton. Larry Belente was the consulting engineer during the restoration work.
It does have the modern concept of if it's too stiff, it will break, and if it has flexibility, it will give with the wind, give with the temperature changes, and therefore be able to, like an airplane wing, go up and down and not break and come to pieces. So this was revolutionary at the time, and it absolutely is the only way you could have done this and had it survive as long as it has.
There are plans to use this technology to rebuild the Colossus on the island of Rhodes. Nicolas Kotsiaminas, one of the leading bronze sculptors in the world today, dreams of recreating the Colossus. He has already made some enormous bronzes. He now plans to build the Colossus to stand the height of a 15-story building.
I'm proposing two different designs. The first one is going to look as the old Colossus by putting this arm like that, okay? Of course, now, with the new technology, we do something different. And now I'm proposing the second proposition is to stretch the arm, giving the light to the world. Okay, now we've got the technology to do that. Along with Liberty, it's going to be the largest. But it's going to have one advantage over Liberty, simply because it's connected with this sort of thrill. One of the wonders of the world is going to be recreated. And that's the main thing. That's the beauty of it.
In the 3rd century BC, the fallen Colossus remained a wonder of the world. Tourists flocked from all over the Mediterranean to marvel at its giant remains. An oracle predicted that Rhodes would suffer great misfortune if the statue were rebuilt. So it was left lying where it had fallen for 900 years. Charis, like the Colossus he created, became a broken man. One story recalls how he miscalculated the cost of doubling the statue's size, leaving him bankrupt. Destroyed by debt, he committed suicide. The last of the 7 ancient wonders was built in the city that had given birth to them all, Alexandria. The city was the world's first metropolis, and its world wonder the first skyscraper. Known as the Pharos, it was a lighthouse standing over 400 feet high. Lighthouses had been built around the Mediterranean from as early as the 7th century BC. But the Pharos was more than a beacon. It had another function.
Here we have a tower which expresses the power and control and prestige of the Ptolemaic dynasty, the kings of Egypt of the time.
Alexandria was the first megacity. Palaces were stacked upon palaces, yet the Pharos exceeded everything else.
It is yet another way in which Alexandria can be put at least one notch, and preferably several notches, above every other city in the world.
Built during the reign of Ptolemy II, the Pharos announced to the world the grandeur of Alexandria. Designed by the architect Sostratus of Cnidus, it took 12 years to construct. At the top, a vast furnace was kept raging. It blasted its golden light 50 miles out to sea. Some reports mention extraordinary solar mirrors used to laser enemy ships at sea. The Pharos was built in 3 sections. On the base sat a square tower, 233 feet tall. The second section was octagonal, and above it was the lighting apparatus. It's believed a spiral rampway inside allowed donkeys to take up the loads of fuel.
We know that it did have ramps inside it, and that donkeys, for instance, could perhaps have gone up to the top of it on these ramps carrying loads. But it's a bit of an open question as to exactly how it worked, I think.
The light at the top was created by a furnace. It was directed out to sea via large bronze reflectors.
One of the problems, of course, of a lighthouse, particularly in a location such as Egypt, which is relatively poor in trees, in wood, would be what do you actually use to feed the flames?
Alexandria was the largest port in the Greek world, and it is likely that the city had access to many raw materials. Various fuels have been suggested, ranging from wood and oil to fats and tree resins. The Pharos was built from solid blocks of granite and limestone. Unlike tall buildings of today, its walls had to bear all the weight of the masonry above.
Modern buildings have very thin outer skins, sometimes entirely glass, and the walls themselves carry no weight at all. This is achieved by using a frame. I'm holding on to one of the steel stanchions here, so the ground floor and the interior can be entirely open. Frame technology was only invented relatively recently with the advent of modern materials like steel and concrete. Because the ancients were limited to stone, they had to build enormously thick and heavy walls to reach the heights that they wanted.
In the 19th century, Jules Bordet, a forerunner of Eiffel, made the most ambitious copy of the Pharos. Although never built, he incorporated a metal frame into his design for a tower to light up Paris. Built entirely from stone, it is unclear how the Pharos could stand so tall. Yet there are many ancient accounts of it.
The Pharos of Alexandria is actually one of the better documented of the Seven Wonders. It ceased to be a lighthouse at the end of the classical period, but it went on to be used as a mosque. In fact, what they did was on the top where the lantern had been, they built a mosque. There are Arab historians who had climbed it and give very good detailed descriptions with dimensions. So we can be fairly sure that it really was as it's described.
Today, a medieval castle stands on the site of the Pharos, which stood until 1303. Named after the small island on which it was built, Pharos has become a generic word for all lighthouses. Like the mausoleum in Colossus, the Pharos was destroyed by an earthquake. For 700 years, its remains lay on the seabed. But recently, a marine archaeologist has begun bringing to the surface the world wonder that has remained hidden for centuries. When the Pharos was toppled into the sea, its massive building stones were scattered across the harbor. Marine archaeologist Jean-Yves Empereur has been excavating the underwater site. He still can't comprehend the scale of his discovery.
When, for the first time, we dived, we couldn't imagine such chaotic and huge underwater collection of such thousands and thousands of columns, of bases of columns, of capitals, of sphinxes, of obelisks, and so on. It was incredible. And every time we dive, even now, after thousands of diving here, we go back to the surface with a strange feeling. It's a fantastic sight. You cannot imagine, you cannot describe it. You have to dive to have this so strange feeling.
Among his discoveries was a vast granite lintel weighing 75 tons, which he believes to be a supporting beam from the Pharos.
So we are on the place here, on the underwater site. This is a slip from where we jump into the water.
Jean-Yves has been diving here since 1991. The vast underwater site covers 5 acres. His team continues to log the size and weight of every block. One day they hope to establish once and for all how the Pharos was constructed. The world's tallest lighthouse was brought down by an earthquake. Nowadays, tall buildings are thoroughly tested. Gavin Davis examines the stability of the Pharos.
There's no doubt this would have been a very challenging structure to build, but to build something that's supposedly 400 feet tall or more would have been very difficult at that time. When comparing the Pharos with one of the Great Pyramids, for example, you can see that there's a great difference because the pyramids are inherently more stable structure. Comparing it to something like a pyramid, which would have a much wider base, then it really is still a very tall and thin building.
Whereas the ancients were building into the unknown, today's architects are required to check every uncertainty.
This building's the Hong Kong and Shanghai Bank, and a significant amount of testing was carried out to look at how it might behave in the wind. The computer these days allows us to eliminate even the most unlikely problem areas from buildings, which means that we can design closer to the edge and design buildings that perform better.
Today's architectural wonders stand within the safeguards of science and technology. The 7 wonders have become icons of the ancient world. They stood not solely by the laws of science, but by the will of an age determined to build the impossible.
The 7 ancient wonders were part of an age of optimism, an attempt to use technology to the limits, to go further than people had ever gone before in creating these massive monumental structures.
Architecture and sculpture continue to pay a debt to the excellence of their construction.
Still, there is this notion that in antiquity there were 7 structures that were the epitome of magnificence and achievement.
The 7 ancient wonders challenge the finest minds. Even now, we still wonder how to match them.
If we tried to make a list of today's wonders, could we find 7? Or would we find 200?
Their high ideals have stood the test of time. They remain the cornerstones of our finest constructions.
Architecture has to serve a purpose. And I think the symbolism of the pyramid is as valid, in my opinion, today as it was then.
The 7 wonders of the ancient world set the supreme standard and keep alive the dreams of the ancients.